Hello, so I will tease about our paper on Skolem. What is Skolem? It's a question on linear transformation. For instance, take a matrix of dimension k. It will define a linear transformation by applying repetitively m. For instance, so the Skolem problem is given an initial configuration C. Is there an iteration such that the first component of the iteration is null? Similarly, for positivity, is there an iteration such that the first component is negative? Surprisingly, while everything is linear, all the coefficients are rationals, we do not know how to solve these questions. Okay, we know how to solve them only for very small dimension, up to 4, and above that, it's unknown how to do, and it's also actually known that it's very hard. So the pitch of the paper will try to provide a graphical interpretation of the fine mathematical result there is on Skolem. So for instance, consider a configuration C, and let's see whether it's positive, which means that whether all its iterates lie in the half space defined by x is positive. So this is a very hard question, right? So let's try an even harder question, which is consider the set P, try to characterize the set P of configuration which satisfy positivity. So if C is positive, so all its iterates will be positive and they will all be in this set P. In general, of course, we do not know how to characterize P exactly. So instead, what we will do, we will approximate P. Well, we consider the dominant eigenspace of M, the matrix. Basically, we'll just consider the restriction of M on its eigenvalue of maximal modulus. So it gives rise to a matrix M dom. And the good thing about it is that we can characterize exactly its positive set. We can characterize it exactly as a high-dimensional cone. Okay, and on top of that, which we call P dom, and on top of that, P dom, we can show that it includes the projection of P on the dimension of the dominant coefficients. So now that we have that, we can also consider the image of the half space H0 by M, okay, and its iteration. And by definition, P will be exactly the intersection of all these half spaces. So with these two results, what we can do is we can approximate the projection of P by P dom intersected with the n first projection of Hn plus. And this will approximate pretty well projection of P, and this will be enough to handle robustness of positive of Skolem, as I will present to you at stacks. Thank you.